These are the Algebra 2 12.3 notes. So we're talking about the determinant of a matrix. When you're finding the determinant of a matrix, it can only be used on a square matrix. And so what we mean by that is it could be a 2 by 2, a 3 by 3, a 4 by 4, etc. We're only going to learn about a 2 by 2 and a 3 by 3. All right, so we're going to use the space over here to find the 2 by 2 matrix. All right, if you are finding the determinant of a matrix that's a 2 by 2, they put the DET outside to represent determinant. Then I'm just going to put letters in here to represent each number in the matrices. All right, and so another way they write it is just with these vertical lines. They kind of look like absolute value lines, but when it's referring to a matrix, it means that it's the determinant. So the way they notate it is with the DET outside the matrices, or with these vertical lines right here, that tells you find the determinant. Okay, and what you do here, I'm going to switch to where my highlighters show. All right, so what you do, it's pretty easy once you kind of get the pattern down. You are going to take A times D, and the order of multiplying AD doesn't matter, but it matters that you do the A times D first, and then you are going to take the B times the C or C times B. That has to go second, and then you subtract them. That is how you find the determinant. Let's stop and do that real quick with example 1a, and then we'll come back and we'll do the 3 by 3. So if we want to find the determinant, we are going to take, and it does matter that you do the 2 times the 4 first. So you do 2 times 4, and then you're going to do the 1 times the 5 or the 5 times the 1. That has to be the second thing, and then you subtract them. So 2 times 4 is 8. Times 1 is 5, and then you subtract them, and you get 3. So the determinant of this matrix is 3. All right, let's go ahead and also write down instructions up here for a 3 by 3 matrices, and then we'll go ahead and try it. So on a 3 by 3, that would look like this. They're going to write DET for determinant. And we're going to fill it out. So it's going to be A, B, C, D, E, F, G, H, I. And these are just standing in for the numbers. So when we find the determinant, once again, they can write determinant, or they can put it in what kind of looks like absolute value brackets. It's really not, just these vertical lines. Okay, so how you do with a square matrices. You're going to start and you rewrite the first column and the second column out to the right side. So the first column is A, D, G, and then B, E, H. So you just write them out to the side. Now, honestly, it's very similar to a 2 by 2. There's just a few extra steps. So what we're going to do, let me get my highlighters up here. All right. We're going to take A times E times I. So that'll be A times E times I. And then we're also going to do B times F times G. And then we will finally do C times D times H. Some people call this the lattice method. I don't really have a specific name for it, but I see that a lot. And then you take those and you add them together, and that creates your first number. So you're multiplying at a angle going down. All right, and then you're going to do something similar, except you are doing the other direction. So right here, you're going to have this diagonal, which is C times E times G. So C, E, G. And then you also multiply this diagonal, H, F, and A. So I call that A times F times H. And then you also do the last diagonal, which is B times D times I. You add those numbers together, and they create the second number, and that's the two numbers you subtract. All right, so I think it makes more sense once we get down here and actually do it with a matrices. I'll be honest, I don't typically rewrite them just to get the determinant bars on the side. I just go straight from where I'm at here. And so I'm going to repeat my first column and then my second column. All right, and now I'm going to figure out, I'm going to multiply 3 times 0 times 1. And we're going to multiply 4 times 6 times negative 2. I'm going to do negative 1 times 2 times negative 3. All right, those numbers you add up. So 3 times 0 times 1 is 0. 4 times 6 times negative 2 is negative 48. And then negative 1 times 2 times negative 3 is going to be 6. So altogether, that creates negative 42. All right, now we're going to find the other number. And remember, it's created by doing the diagonals going the other way. So negative 2 times 0 times negative 1, that's 0. All right, and then we're going to do negative 3 times 6 times 3. All right, let's see here. That's going to be, I think, negative 54. And then 1 times 2 times 4, which is going to be 8. And so that number, negative 54 plus 8, is negative 46. You are subtracting them. So negative 42 minus negative 46 ends up being 4. And that's the determinant of that matrices. Okay, I'm going to go ahead and encourage you to go to the self-assessment and try these two. I'm going to pause the video. I'd encourage you to do the same. Just pause the video, try it, and then come back on and check your solutions. All right, so here's the solution. Feel free to pause and look closer to check and see that you're correct. Let's go ahead and let's revisit the area of a triangle. We hadn't finished that up here. All right, and so when you have a triangle, it doesn't matter how the triangle is. So I'm just going to graph some random triangle on here. All right, so the 3 points, it doesn't matter which point's which. One of the points is x1, y1. One of the points is x2, y2. And the other point will be called x3, y3. So when you want to find the area of a triangle, what you're going to do is you're going to do the area equals, you do plus or minus 1/2 times the determinant of the points. And how you put the points in, you put x1, y1, x2, y2, x3, y3. But remember, you can only find the determinant of a square matrix, so fill in that last column just with ones. All right, and so the reason why it is a plus minus, it adjusts the sign. So like if it comes out negative, you turn it into positive because the area has to be positive. Always. It's a positive measurement. All right, let's actually just go ahead and try it. So it doesn't matter which point you consider, point 1, point 2, or point 3. So like I'm just going to call this one point 1 right here. So it's 2, 3. And then I'll call this one point 2. It's 3, negative 2. And this is point 3. And like I said, it doesn't matter. It's just that the first column's x's, the second column's y's, fill in the third column with ones. Now, if we want to find the determinant, remember you rewrite that first column and the second column outside. All right, and so we are going to go ahead and find these 3 right here. And then we're also going to find these 3 here. So just like we had done with the determinant. All right, and so I am going to, let's see here, have 2 times negative 2 times 1, 3 times 1 times negative 4, 1 times 3 times negative 3. All right, and then I'm going to have the blue ones, which are negative 4 times negative 2 times 1, negative 3 times 1 times 2. Squeeze this in here, 1 times 3 times 3. All right, so I went ahead and just did that in a calculator. I ended up with negative 25 and then minus 11. So that's negative 36. So the area is plus or minus 1/2 negative 36. So if I do half of 36, I get 18, and I always choose the positive version. So it's 18 square units or units squared. So that's what the plus and minus does. You should always, always, always have a positive area.